Hi, my name is Ryan Kazemi, and I will be your math tutor today at the Digital Learning and Academic Support Center at Baton Rouge Community College, commonly known as BRCC. This is my first math video, and I chose an actual exam problem for the GED, which is the high set nowadays, that covers all the rules for exponents in one problem. And we're going to learn all of those rules through studying this problem. Hi, this is Ryan again, and this is the problem involving exponents that is going to help us review all of the rules for exponents. And as mentioned in the introduction, this was an actual GED test question. And so here, if you look at this problem, you will see that we have a certain amount of numbers. There's a 2 right here. Excuse me really quick. There's a 2 right there. We have some numbers, we have some A's, and we have some B's. And the problem is asking us to simplify. And simplify in math means make it more simple, or in everyday terms, see if you can take anything out, right, and take things out of the picture. So here, what we're first going to do is leave a space for our final answer so we can compare at the end, right, what we have to what we created. Okay, the next thing we're going to do is, under our final answer, we're going to have some side notes along here as we progress with this problem. And the first side note is that we have an a to the 0. And the first rule with exponents is that anything to the 0, right, is 1, because 1 is the identity in multiplication. So before we even start, right, and there's a power to the 3 here also in this problem. So now the problem is correct. This a to the 0, whatever that a is, becomes a 1 because it's a power to the 0. So that's the first thing we can do when we look at this, the first rule we learn. So what we're going to do is, all of this is to the 5, and all of that is to the 3, everything in the parentheses. So we're going to apply that 5 to everything and that 3 to everything. And so our first step is going to say negative 2 to the 5, a to the 5, b to the 3 to the 5, I haven't done anything with that yet, times 1 to the 3 over, and I'm going to keep everything down here right now, 4b to the 2, all of that to the 3, right? So the same way we spread that 5 across to everything in multiplication, we're going to do that at the bottom of that fraction, but also in this step, we're going to multiply whatever that is with the fraction. And the way we're going to do this is we're going to go back to our side notes, and we're going to say that a number times a fraction multiplies with the top. And the way we explain that is that any number is over 1. How many times can I fit 1 into 3? 3 times. So it doesn't change that 3. And it's top with top, bottom with bottom. So that 3 would multiply with that 4, and that 4 over 5. So whatever we got here at the top is going to multiply with the top, but that top is 1. Because 1 to the 3 is 1 times 1 times 1. 1 to the 27 is 1. 1 times 1 times 1 times 1. So at the top, we now have 2 to the 5, a to the 5, b to the 3 to the 5. And at the bottom, we're spreading that to the 3 to everything. So that's 4 to the 3, and b to the 2 to the 3. Okay? Again, we have some numbers, and we have the letter A and the letter B with some numbers. Okay, so our next step is, since we have numbers, A's and B's, we can actually separate those and work them separately as long as we're keeping track of what we're doing in our final answer. So our numbers are minus 2 to the 5 over 4 to the 3. I'm actually going to keep that for last. Our A's, we see there's only one A term left, a to the 5. So that a to the 5 is going to be in our final answer. And then for B's, we have this business here of b to the 3 to the 5 over b to the 2 to the 3. And we ask ourselves, well, what do we do with this, right? And we're going to tackle this in a second. So let's go to our final answer and put our a to the 5, and then figure out our number, which we're going to put in front, and our b's, which we're going to put in the back of that final answer, okay? So now we're in our side notes, and to figure out what to do with, let's say, b to the 3 to the 5, we're going to use 2 and 3 and a different number, right? So if I tell you, again, 8 to the 4, that's 8 times itself 4 times. Why do we do this? Because this happens so many times in math that we developed an entire notation and math calculations for this kind of stuff. So here, we're going to use 2 and 3 with the number 8. And what we're asking ourselves is, what do I do here? And what do I do here? And the reason we use 2 and 3 is that it's going to make all of this easier. Once we understand it with 2 and 3, we can do with bigger numbers. So 8 to the 2 to the 3, right, is taking this 8 to the 2, multiplying by itself 3 times. So that's 8, that's 8 times 8 in the middle of that parentheses, 8 to the 2, but the whole thing to the 3. So that's, right? And technically that's times in between these things. So how many times does it show up is 6. And 6 is 2 times 3. That's why we pick 2 and 3 to see what happens. So the rule here, the power rule is called, but the rule here, maybe I haven't done this in many years, right? A lot of people taking the high set, haven't touched math in some years. Is to remind yourself with 2 and 3 that you're multiplying here. And the same way, this is 8 to the 2 times 8 to the 3. So if we're multiplying up there, this is to the 5, and 5 is 2 plus 3. So in a scenario like this, if the other one we're multiplying, this one we're adding. So the first thing we're going to do here with our, let me line this up here, with our b's, before we figure out what to do next, is multiply them. So that's b to the 15, right? 3 times 5 over b to the 6. So now we made a step with the b's, but we still got to figure out what this is. And I'm going to show you the rules here, but I'm also going to show you a way of doing this if you forget the rules, a fallback plan. So the rule here is that any exponent under a fraction can be brought up with a negative sign. So this b to the 15 would be, well, that's not a 15, is it? This is? Would be times b to the minus 6. And we just saw the rule here, right? We just saw the rule here that we add them in this scenario. So 15 minus 6 is going to give us an answer of b to the 9, right? And here we had an a to the 5 for a as our final answer for b. But let's say I forget this stuff here and I have a b to the 15 over b to the 6. Well, if I have a b to the 3, I can write that as b, that's multiplied. So all I have to do is keep track. And at the bottom here, I have 6 of them, right? Doing them 3 at a time. And then I got 15 at the top. It's a lot. But if I forgot the rule, I can fall back on this. That's 9, 12, and 15. Okay? And 1 over 1 cancels out. Simplifies is the correct math word. Takes out. Right? But here I can do 3 of them. 3 of them. And how many do I have left? I have 9. So this is a fallback plan if you forget that b to the 6 can become b to the minus 6, right? So now we have our a's and our b's. We found that our final answer has a b to the 9. We also now can deal with our numbers, and our numbers were here, minus 2 to the 5 over 4 to the 3. So minus 2 to the 5 over 4 to the 3. Now, I know that 2 and 4 are related somehow, but I got some minuses in there. It's not as obvious what to do right off the bat. So what I'm going to do is I'm just going to write this out and see what I can do. So the bottom is 4 times 4 times 4, and the top is minus 2 times itself 5 times, right? So we did this right. That's 5 of them. So here's the deal. Minus times minus is plus, and 2 times 2 is 4. So I can actually take out 1, 4 and 1, 4 here. I can do it again here. So all we have left now, right, I went a little too far. We have a minus 2 left at the top and a 4 at the bottom. That's the same as minus 1/2. So now we have our number that we can put in our final answer, right? So what we did again is separate our numbers, our A's, our B's, to figure out what's the end result for A, B, and our numbers, right, which we did. And then we put it in the final answer. And I want you to compare here the original problem, which was all of this stuff, and the final answer next to it, how simple it looks at the end, okay? So on a GED high set exam, you would have 5 choices. This would be one. This, depending on how your answer is represented, could also be written as over 2, right? That's half. When the negative, don't forget the negative in front, right? So those two things mean the same thing. So now let's take a look at the entire problem, right, that we just worked, right? We went through our calculations. We separated, right, to find A, B. A was obvious, B in the numbers, right? And we had our final answer next to our original problem with some side notes on the side.